It's only grade D apparently. So 2x plus 5, got to prove that, plus 11 into x minus 2 is equivalent to 3 lots of 7x plus 1. Now, don't touch the right hand side, but you've got to reach it somehow. Now let's do the left hand side. LHS is acceptable, shorthand. Multiply out 10x 25 11x minus 22. Simplify that. I have got 21 x's, 25 take away 22 is plus 3. If you've now factorised, I get 7x plus 1, and here I factorised. So factorising. So I proved that, and that is of course the right hand side. Fair enough. Next little bit. Prove that 11 bracket x minus 1 plus 4 lots of, getting a bit laggy, x plus 14 close bracket is equivalent to 15 bracket x plus 3. Again, break it open, go for the left hand side. It's going to be 11x minus 11 plus 4x plus 40, 56. I'm simplifying. We're going to get 11x plus 40 plus 4x is 15x's, minus 7 plus 56 is plus 45, and now we're going to factorise. Taking out 15 as a common factor will be x plus 3. And that was factorising. And that equals the right hand side. Easy peasy. That's grade D. I think it's worth a bit more than that, honestly. Let's go to another page. I'm going to miss that out. Prove that the sum of two consecutive odd numbers is always an even number. Here we go. Two consecutive odd numbers. So if x is odd, and the next odd number is going to be 2 along, isn't it? X plus 2. So the sum of, that means add them. So that becomes 2x plus 2. Factorising that, we're going to get 2 bracket x plus 1. Now, if x is odd, then x plus 1 must be even. Fair enough? Because that's 1 along from the original x. And 2 times x plus 1 equals 2 times even, and therefore it's even. Is that alright? Proven. That's alright. Right, prove that the sum of the 3 consecutive numbers prove that the sum of 3 consecutive numbers is equal to 3 times the middle number. Okay. Sum of 3 consecutive numbers. So x, x plus 1, x plus 2. Is that fair enough? And they're consecutive, and it says sum. So I'm going to come along and add them. Get some answers here. 1, 2, 3. 1, 2, 3. So I've got 3x plus 3 is equal to 3 times the middle number. I'm going to factorise it. I can get 3 out of that, and that's going to be plus 1, factorising. And here's my punchline. 3 bracket x plus 1 is 3 times, my pen's not working very well, 3 times x plus 1, okay, and which is the middle number. And that is the middle number, so I'm going to leave it like that. Not going to do that one. I will do question 9. It's grade A, so let's just give it some attention. Prove that if you add the squares of 3 consecutive numbers, so here we go, x x plus 1, x plus 2. These are consecutive numbers. Prove that if you add the squares, so let's square up. I've got x squared here, if it lets me write it. If I square this one, I've got x plus 1 squared. I'll multiply that out in a minute. If I square this one, I've got x plus 2 squared. So let's just tidy this up a little bit. Here I've got x squared plus 2x plus 1. Here I have x squared plus 4x plus 4. Prove that if you add the squares, alright, let's add them then. So I've got x squared, and let's add that to the second number squared and that to the third number squared. What will I get? I'm going to get 3x squared plus 6x plus, let's make it look more like an x, not like a scribble, and 1 plus 4 is 5. So that's simplified all up. So prove that if you add the squares of the 3 consecutive numbers and then subtract 2, okay, 3x squared plus 6x plus 5, subtract 2, I'll get an answer with a multiple of 3. Okay then, so that equals 3x squared plus 6x plus 3. Look, I'm now going to factorise, and that becomes 3 brackets x squared plus 2x plus 1. And what I've proved here is that 3 multiplied by x squared plus 2x plus 1 is a multiple. It's really hard, it's so laggy. Is a multiple of 3. I think I can factorise that anyway. I don't think I need to do that, or do I? Anyway, just to see what happens, I'll make that x plus 1 all squared. There you go. I prove that if you add the squares of 3 successive numbers and then subtract 2, the answer is a multiple of 3. And the fact that that equals x plus 1 all squared is a coincidence, I think. So that's that. Right. Question 10 is very, very deep indeed. I'm going to go for it. It looks absolutely stunning. It really does. I've got to prove this. So n plus 1 all over n, and I take away n over n plus 1. That's equal to 2 bracket n plus 1 close bracket all over n bracket n plus 1. Now if I land this, I'll be delighted. Anyway, what I want to do is to work on the left hand side and somehow arrive at the right hand side without missing too many steps. If I miss too many steps, I won't be able to convince Mr. Examiner I know what I'm doing. I'm just sort of missing out loads of steps and grabbing this end part and saying, yeah, it works. It doesn't. Let's just carry on. Common denominator. Left hand side, right? I've got this, and it's going to want that, isn't it? Multiplying top and bottom by n plus 1, that is. And this side is going to want the n, so it's going to be n times n. Again, could have called it n squared, I didn't want to do that. Let's multiply this all out and see where we go, shall we? Let's go across the page, or across the screen. Multiplying this out, I've got n squared plus 2n plus 1, and then take away n squared because n times n is n squared. Divide that by n over n plus 1. Now I'm not inclined to multiply this out for the simple reason that in the final answer we have n over n plus n bracket n plus 1, so there's no point in doing that. Let's just simplify the top bit a little bit. The n's squareds disappear, and I'm left with, there's something not quite right here. What is it? Oh no, there's no bracket there. It's totally correct, but this has got no bracket, and that threw me a little bit. It's so laggy, this is just not working now. Let's lose that. Yeah, that was never there. Sorry, my mistake. And that made everything very, very confusing. Let's get rid of all this. And we'll carry on. Yeah, it was never going to be that. What I'm left with now is 2n plus 1 upstairs divided by n bracket n plus 1 downstairs. Triangle number is given by the formula half n multiplied by n plus 1. And the easy part says write down the first three triangle numbers. Well, when n equals 1, I've got half times 1 multiplied by 1 plus 1. So half of 1 is 1, 1 plus 1 is 2, half times 2 is 1. Now when n equals 2, it's going to be a half multiplied by 2 multiplied by 2 plus 1, and that's going to give me, let's work it out, well, half of 2 is 1, 1 times 3 is 3, and the last one, n equals 3, a half of 3 multiplied by 3 plus 1. It's really not responding well, this at all. What have we got? Well, 3 plus 1 is 4. Half of 3 is 1 1/2. 1 1/2 times 4 is 6. And these are triangle numbers. 1, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay? These are triangle numbers. That's how they look in terms of drawing them out as a pattern. Now here's the really good bit here. Let's underline that and just get rid of this little bit here because that was just peasy. Now here's the really dangerous stuff. Okay, let's go. Prove that the sum of any two consecutive triangle numbers is always a square number. Right, so let this be my first triangle number. It's called half n bracket n plus 1. Now the next one along will be where n is 1 more than the previous n. So I've got half bracket n plus 1 multiplied by n plus 1 plus the one that's already there originally. Okay, so if you like, this has become my new n, my next number along, and this has become my next number along. So whereas it used to be n, it's now n plus 1. Can you see what I've done? So right, let's just multiply this out. It does say the sum of, so eventually I've got to add these two bits and pieces and maybe arrive at a square number. Let's just begin to be faithful to the maths. Right, multiplying out, I've got half n squared plus a half. That's that bit sorted. Plus, let's multiply out, let's simplify this a little bit first. I've got half bracket n plus 1 close bracket multiplied by n plus 2. Is that alright? That's that bit simplified. So can't do any more than this at the moment. Half n squared plus a half. Well, that should be half n, by the way. Half n times 1. Yes, half n. Of course it is. Make that look less like a p and more like an n. Again, this laggy stuff is getting to me. Right. Add on a half of. Well, let's just multiply this entire thing and then halve it later. We've got n squared plus 2n 3n plus, well, 1 times 2 is 2. Close it off. Let's do the next line. Half n squared plus half an ordinary n, now we can multiply out, plus half n squared, half times 3 plus 1.5 n's, and half times 2 is 1. Simplifying, I have got n squared plus n squared, let's go back to yellow, n squared plus n squared, half n squared plus half n squared is a proper full n squared, half an n plus 1.5 n's, that's called plus 2 n's altogether, and plus the 1 at the end. Now look at it carefully. I can easily factorize that as follows. N plus 1 multiplied by n plus 1. That is a perfect square. If you multiply this out, you will get n squared plus 2n plus 1, and that becomes n, if it lets me write it, please, n plus, oh, it won't let me do it. n plus 1 close bracket all squared, and therefore that is a square number. I've proved that the sum